What's up everyone, welcome back, Patrick here, and in this video we're going to solve this limit here. So the limit as x approaches 0 of 1 over x times root 4 plus x minus 1 over 2x. And this limit is actually, it's pretty neat. I'm going to show you two different ways to do this. One way is we can rationalize this. So notice we have this square root here, and when we rationalize it we're going to get rid of the square root, do algebra, and it's going to work out. And then another way is we can actually do a change of variable as well, which is going to be a little bit more complex in my opinion, but I'll show it to you anyway. Now, we can actually rationalize this in two different ways. Notice that first, we can't do a direct substitution, because if we sub in 0 for x, notice that this denominator would be 0 because of this x here, and this denominator would be 0 because of that x right there. So we can rationalize this. One way to rationalize it is we can actually multiply this by its conjugate. Notice we have an expression minus an expression. So the conjugate of this would be 1 over x root 4 plus x plus 1 over 2x. And we'd multiply this by that, and then this by that, and that would get rid of the square root. Now, we can't just multiply it by its conjugate. We got to multiply this whole thing by its conjugate over that same conjugate. And actually, this is why I don't recommend doing it this way, because it's just going to get really messy. You can do it this way, but now you're going to have to work with like these fractions up top, and then this fraction is going to have to be at the bottom. And it gets pretty crazy, but nevertheless, you can do it this way. You could try, and you should get the same answer that we got before. Basically, when you multiply this by this, you'd end up with 1 over x squared, 4 plus x, right? When you multiply these and this. And then if you multiply this and that, you'd end up with 1 over 4x squared. And you'd have to combine these into one fraction. And then these x squares with something up top should cancel out, and then you can make a direct substitution. So that's one way to do rationalization. I don't recommend it. What I actually recommend before doing rationalization is actually combining these into one fraction. So the way we can do that is, notice that we have a fraction minus a fraction. So to combine them, since we're subtracting fractions, we have to get a common denominator. So notice that we have these factors here. We have x, we have root 4 plus x, we have this 2, and then we have this x here. So to get a common denominator, notice that this factor, this denominator, we can multiply by 2. And then these two factors, we can multiply by root 4 plus x. And now notice the three factors in both of these denominators are going to be the same. But if we multiply something here, we got to multiply it up top as well. So we have to multiply that 2 up top. Here we multiply by root 4 plus x, so we got to multiply the top by root 4 plus x as well. And so now what's going to happen is we'll have 2 minus root 4 plus x. 1 times that is just that bracket itself. So we'll have 2 minus root 4 plus x in the numerator over, combining these three factors, we'll have 2x and then root 4 plus x. Like that. So we took those two fractions, made them into one fraction, like this. And now what we can do is we can rationalize. We would rationalize that numerator. We can multiply by the numerator's conjugate, which would be 2 plus root 4 plus x. So those ends we keep the same, we just change the sign in the middle. But we got to multiply the bottom by that same conjugate. So it's like we're taking this expression, multiplying it by 1. Keeping that expression the same, just kind of adding more to it. And now notice that this conjugate just way smoother to work with than that conjugate that we had before, where the other conjugate had like fractions within it, and then we had to have that same conjugate in the denominator. Here, we don't have fractions in the numerator, fractions in the denominator. They're just sort of normal expressions. And now what we can do, when we multiply this by that, this is a difference of squares, so we could just multiply the ends. So 2 times 2 is 4. and then the middle is always going to be a negative, and then root 4 plus x times root 4 plus x, that just gives us 4 plus x, like that. And then these two, I'm just going to keep separate. So we got this 2. You know what? I'm going to keep the 2, the x, and then the root 4 plus x separate. Right? We're just multiplying these. So we got those 3 factors multiplied by this factor, which is 2 plus root 4 plus x. That entire expression is a factor. And so what's going to happen from here is we can simplify the numerator. So we can distribute that negative inside the bracket. Notice 4 minus 4, that would be 0. Distribute that negative to this x, so we'd just be left with a negative x up top. And then we'll have 2 times x times root 4 plus x times 2 plus root 4 plus x, like that. And now notice the x's cancel out. So we wanted to get rid of that x in the denominator, so now we could plug in 0 for x. And so there's a negative 1 left up top. And so now when we plug in that 0 for x, we'll have negative 1 up top over, we have this 2 here. This x went away with that x, and then we have root 4 plus x. If we plug in 0 for x, we'll just be left with root 4. And then this whole factor would be 2 plus 4 plus 0 is 4, so we'll just have root 4 right there. And so this would be negative 1 over 2 times 2. And then this would be 2 plus 2, right? Root 4 is 2 plus 2, that gives us 4. 2 times 2 times 4 gives us 16. So negative 1 over 16 is the answer to this limit. And if you did it that first way I showed you, where those conjugates you multiplied were more complex and you decided to do the algebra from there, you should get that same answer. Right? But again, I don't suggest doing it that way. I suggest combining the 2 fractions into 1 fraction first and then rationalizing from there. It's just going to be a lot less hectic, a lot less algebra, and a lot less risk of making a mistake. So negative 1 over 16 is the answer. Now, another way you can do it, a totally different way, is you can actually use a change of variable. So we wouldn't even do rationalization. So let me rewrite this limit again. So we have the limit as x approaches 0 of 1 over x root 4 plus x minus 1 over 2x. That was the original limit. And what we can do is we can introduce another variable, let's call it m, and we're going to let m equal this square root here. So it's going to equal the square root of 4 plus x. And so what we have to do is basically for all the x's in this limit, we have to sub in for all those x's expressions in terms of m. So for this root 4 plus x, we could just plug in this m here. But what about these x's here by themselves? Well, what we got to do is we got to isolate for this x over here. And it's going to be in terms of m. So what we can do is we can actually square both sides. So when we do that, we'd end up with m squared equals 4 plus x, right? The square root of something squared is just whatever's under that square root. And what we do to the right side, got to do to the left side as well. So this and this are the same, and then we just bring the 4 over. So we'll have m squared minus 4 equals x. So now notice that we got expressions that we can sub in for the x's. We have an expression that we could sub in for this root 4 plus x. We also have to have an expression that we could sub in as x approaches 0. And notice as x approaches 0 up here, then this, the m is going to approach square root of 4 because it'll be 4 plus 0, which would be 2. So as x approaches 0 here, the m is approaching 2, and we would sub in that here. So we would basically change this whole limit to be the limit as m approaches 2 of 1 over, this would be wait, sorry, yeah, the x, this x is going to be m squared minus 4. This root 4 plus x is just m minus 1 over 2, and then this x is going to be m squared minus 4. Like that. And so now we have this new limit without this square root to deal with. So there's not going to be any rationalization to do, but there is going to be a lot of algebra. So what we have to first do is combine these into one fraction. So notice we're subtracting two fractions. Now to get a common denominator, we've got to multiply this by 2, which means we have to multiply the top by 2, and then this here we got to multiply by m, which means the top we have to multiply by m. And so what we'll have is the limit as m approaches 2, here we'll have 2 minus m, over the denominator is going to be 2m, m squared minus 4, like that. I also forgot to mention, notice that we can't make a direct substitution yet of 2, because 2 squared minus 4 would be 0, which would make this whole denominator 0. Same thing here. And same thing here. This bracket would be 0, so this whole thing is going to be 0. So what we got to actually do is we got to factor this m squared minus 4. And so the next line is going to be the limit as m approaches 2. So basically what we're doing is we did a change of variable, and now we're going to have to do factoring. So notice that the m squared minus 4, that's a difference of squares. That factors into m minus 2, m plus 2. And now notice the m minus 2, the 2 minus m, very similar, but they're not the same yet. But we can make them the same by factoring out a negative in the numerator. And when we factor out a negative in the numerator, that 2 minus m is going to change to m minus 2. And now notice that m minus 2's will cancel out. We're left with a negative 1 up top. And because that m minus 2 went away, now we could plug in 2 for all the remaining m's, and the denominator won't be 0. And in fact, what it's going to be, we're going to have the negative 1 up top. We'll have 2 times 2, which is 4, and then this m plus 2, that would be 4 as well. So 4 times 4, 16. So negative 1 over 16, which is the same answer that we got when we did it the first way, the rationalizing way. So two different ways to do it. Personally, I probably would have done the rationalization way where I combine them into one fraction and then rationalize it, but this is another option as well.